Welcome to Ixia product demonstration. We are going to demonstrate how Ixia's Openflow controller solution can be used to install a large number of flows on the switches. In this demo, one Ixia port is used to emulate Openflow controller and two more Ixia ports will be used to send and receive east-west traffic. Ixia's OpenFlow controller emulation is connected to a switch topology made up of 200 switches in a ring. Switch 1 and switch 3 have 100 hosts behind them each. The hosts connected switch 1 are on VLAN 1 and the hosts connected to the switch 3 are on VLAN 3. In this demo using Ix Network OpenFlow controller emulation, we will show how to measure Openflow Switch flow handling capacity by sending a large number of flows and how to validate the forwarding speed of Openflow switches using Ixia traffic capabilities. To start with, one Ixia Openflow controller is configured in the scenario. We have configured the IPv4 address of the controller and number of OpenFlow channels. A channel is a TCP or TLS based OpenFlow connection between OpenFlow controller and switch. Thus, the number of channels is equal to the number of switches the Ix network controller will establish the TCP connection with. In this demo, since the Ixia controller is talking to 200 switches in a ring topology, the number of channels is 200. Modern switches are built to support a pipeline of multiple tables for increasing efficiency. Ix network supports single table operation as well as complex multiple table based operations. In this screen, the end user can mention how many tables the Ix network controller will configure for each and every OpenFlow channel. Ix network also gives the flexibility to support different number of tables across the OpenFlow channels. By default, the number of tables per channel is configured to 0 in Ix network. For this demo purpose, we are going to configure the tables for only 3 switches in the switch ring topology. Once the number of tables are specified, then it is time to define the flows which should be populated by Ix network controller in the flow tables of the device under test. Ix network helps to define a similar set of flows as a flow set. So, the end user configures the number of flow sets for each table. For readability, each table can have a friendly name in Ix network configuration. Next, we will configure items in flow sets or flows tab. Flow sets is Ix network's way of providing the flexibility to group a large number of similar flow configurations. The number of flows column tells the user the number of flows configured in that flow set. The flows in a given flow set are similar in every other aspect except for the matched field value. The subtab flow config allows user to configure some more advanced configurations. One of the notable configurations is to assign distinct priorities for up to 64,000 flows in a given flow set. Next step is to configure the flows in the flow set with match criteria, instruction, and actions. The match criteria wizard can be opened by clicking on the small triangle button at the right edge of the match instructions profile cells. The flow shown here will strip out the VLAN header from the matching packet and send the packet out through port number 2. This wizard provides the flexibility to apply a pattern to the matched field values. For example, increment pattern has been applied to the Ethernet source MAC. That is, the Ethernet MAC start value is 1:1 and is incremented by 1 for each flow. The number of flows decide how many total flows are created as explained earlier. This is another flow set configuration. Users can configure multiple actions for the matched fields. In the flow set shown here, the packets incoming on port number 2 are matched for Ethernet destination MAC, and upon match, VLAN header is inserted in the packet before the packet is forwarded out on port number 3. These flow set configurations allows user to strip host VLAN headers before forwarding to the other switch and insert VLAN headers before forwarding to a matched host. Once the protocols are started, then IX Network helps the end user to verify the results by showing multiple sets of rich statistics. IX Network Openflow Controller solution gives statistics related to session, handshakes like echo and hello messages, packet-ins received, flows transmitted, group messages, meter messages, and many more. Here we are looking in Openflow session status where we get a summary of how many sessions are successful and how many have failed. After verifying the Openflow session status, user can verify the detailed status of the device under test by looking at the learned information. Learned information is the set of statistics and message values as received from the device under test. Users can verify the values sent by the device under test against the values configured in the device. The learned information can be launched by going to the Openflow Controller Emulation tab and by selecting Get OF Channel Learned Info from the right-click menu. IX Network provides a rich set of data in the Learned Information window. For example, in the Openflow Controller Learned Information shown here, users can verify the switch data path IDs and the various capabilities as configured on the switches. The reply state columns inform the user whether the feature reply has been received successfully, as it is quite possible that the controller has established the TCP connection with the switch, but the channel is not yet up and either empty or no feature reply has been received. The learned information also becomes available as a new tab after the learned information window is closed. Here, users can further select more statistics of interest. These statistics will appear in subtabs in the OF Channel Basic Learned Info tab. To fetch the statistics, after selecting the statistics, user has to right-click on the master row and click Send on Demand Message from the right-click menu. Next step is to configure Ixia source and destination ports. The source hosts are configured on VLAN 1 and connected to switch 1. Similarly, destination hosts are configured on VLAN 3 and connected to switch 3. Users can also configure distinct VLANs for each source or destination host. To keep the flow configuration simple, we have only configured one VLAN for all the source hosts and one for all the destination hosts. Since the flows for these hosts are pre-installed, we will now try to validate if the switches can forward the traffic from hosts connected to switch 1 to the hosts connected to switch 3. Using Ixia Openflow Controller, users can configure millions of such flows and install them on the switches. Once the source hosts and the destinations are started, they should be able to resolve ARPs, and the IPv4 layer of the source and destination hosts will turn green in the scenario. The resolved gateway MAC will either show the switch port MAC or the destination MAC. Users can further verify the reachability status by looking at the IPv4 session details and statistics. As seen in the IPv4 statistics here, all the 100 hosts are able to successfully resolve ARP with all the 100 destination hosts. IX network has extensive traffic generation capabilities, and these capabilities can be easily configured by using Ixia's traffic wizard. The traffic wizard takes a user through step-by-step instructions to create traffic between a complex set of sources and destinations. To launch the wizard, the traffic view has to be selected from left side views, and then user can select from one of the three options in the traffic view. In this demo, the L2L3 traffic item has been selected. Here we are going to configure the traffic between source hosts and destination hosts. In the first traffic wizard page, based on the type of the traffic selected, the user will be shown the list of emulations interfaces under the source and destination panes. Once the desired source and destination endpoints are selected, it is time to configure the packets to be exchanged between these endpoints. Clicking the next button takes user to the next page in this wizard. IX network automatically picks the source and destination MACs and IPs from the already configured values. These values are marked as learned information. Users can configure various other fields in the message. This page allows users to configure very complex and distinct packets to be exchanged between the traffic endpoints by allowing the user to assign increment or decrement and various other patterns to the packet fields. The wizard also allows the user to configure line rate traffic with desired mode of transmission, that is continuous, burst, iteration, and time bound. Using these configurations, IX network can help users to send the traffic under realistic network conditions. This page also has options to apply these traffic conditions across ports or traffic flows. In this demo, we have configured 100% line rate traffic with continuous transmission mode. Using the extensive traffic tracking capabilities, users can track the traffic for a variety of chosen fields. The ingress and egress field values can be compared by enabling the egress tracking. The configuration on this wizard page shows tracking the traffic by destination MAC address and comparing the VLAN on egress. Comparing the VLAN on ingress and egress enables the user to verify that the traffic sent by the source hosts on VLAN 1 is received on destination hosts on VLAN 3. The received traffic can be further classified into various latency bins. Enabling latency bin measurement allows user to measure the switch topology forwarding performance under stressed conditions. These are the most commonly used configurations, and users can hit finish at this point of time. Now we can start the traffic by clicking the start traffic icon. Once the traffic starts flowing, the traffic icon will turn red and the traffic item statistics will appear in the stat viewer. Users can verify the loss, throughput, and latency statistics in the various subtabs. Users can further drill down to view these statistics per egress VLAN ID. To do so, one has to select the traffic item and right-click on the menu item Ingress/Egress Statistics and then select Ethernet Outer VLAN ID. This view validates the traffic statistics per egress VLAN. Egress VLAN is nothing but the destination VLAN in this case. Since in our configuration the destination VLAN was 3, the egress VLAN is 3. From this view, users can again select the traffic item and right-click to choose menu item drill down per destination MAC address. Using this drill down statistics, users can verify the traffic for each VLAN as well as each destination host. The extensive traffic features provided by Ix network enables the users to verify, isolate and debug for any discrepancies in the forwarding of the device under test. Next, we will try to find out if there are any queuing and scheduling issues at the forwarding device. These issues can be easily figured out by looking at the latency bin statistics. The latency bin segregates the incoming traffic according to the latency experienced. Users need to first select Flow Statistics tab in the Stats viewer. Once in the Flow Statistics view, user can select the item Edit Statistics Designer from the right-click menu. Clicking on this menu item will launch a window. From this window, users can select the items of interest from the left pane and move them to the right pane and click OK. In this statistics view, users can clearly see the forwarding performance of the switch topology. The statistics tell us that the switch is forwarding all the traffic with less than 0.2 microsecond latency. Users can also observe if any latency bins are receiving more traffic. These statistics help measure the forwarding performance of the switches when the traffic is sent at a stressed condition. To summarize, we have just seen how to use Ixia Openflow controller solution to fully validate the switch flow capacity and forwarding performance. Thank you for your time. Please watch our other product demos for more information.